The climates of Mars and Venus were also shaped by the greenhouse effect.
Venus has an extremely high concentration of CO2 in its atmosphere, and it's blazing, boiling hot at the surface of Venus. And the Martian atmosphere, for instance, is very, very thin, and also within that thin atmosphere there's only a very, very small amount of CO2, and water vapor is also very, very low. And the surface temperature of Mars is frigid, very, very cold.
In the contentious debate about man-made global warming, all sides agree on the physics of the greenhouse effect. It can even be demonstrated in the lab using a FLIR thermocam, a special infrared camera.
So we're going to demonstrate to you how the CO2 absorbs infrared radiation, which causes the Earth greenhouse effect. Infrared radiation is another word for heat radiation, which is coming off my face and which is picked up by a camera that I'm looking at. The camera is sensitive to heat radiation. Between me and the camera is a volume that we will fill with CO2 gas. And as we turn on the gas, my image will slowly fade.
This physical property of CO2, known to physicists for a century, is the bedrock of the concern about global warming. Because the ordinary air in the tube, composed mainly of nitrogen and oxygen, does not block infrared radiation, the camera sees the heat coming off the scientist's face clearly.
And as we turn on the gas, my image will slowly fade.
But when the tube is filled with CO2, or any greenhouse gas, their molecules absorb the heat radiating off his face, blocking its path. As less and less heat reaches the camera, the image fades. If the scientist were surrounded on all sides by CO2, then the effect would be for him to get warmer, like the Earth in